What's up, Glenwood? This is how to do mole-to-mole problems. Now, taking a look back at the flowchart, again, this is Chapter 7, MrWiedeman.com. The flowchart's at the top. It looks like this. This is also used in my previous video, mole to mass and mass to mole. Now, here's what you're going to do. If you are in moles of one substance, you can conveniently hop from moles of one substance to moles of another. Okay? So I'm going to label this A and this substance B. So if I start off in substance A and I'm in moles of that, you can hop to substance B if you're in moles by using a balanced chemical equation. So I'm going to show you how to do that. I'm going to do that for one problem off of a worksheet that looks like this. This is mole-to-mole problems. I'm going to do the first problem up here. I'm just going to do my work right on the worksheet. So here's how you do a mole-to-mole problem. Again, you can only do this when you are already in moles of a substance. You can hop from one to another, and that's called the mole ratio step. So this box just says mole, but it's called the mole ratio step, hopping from one compound to another using a balanced chemical equation. For example, how many moles of hydrogen are needed to completely react with 2 moles of nitrogen? So hydrogen is the substance H2, and completely react with nitrogen, that's substance N2. So taking a look at this, how do you figure out what you're starting in? You figure out what you're starting in by finding a number, a unit, and a substance with 2 moles of nitrogen. That's what you are always going to start in. So what I mean by start, that's what goes in your start box. So 2 mole of N2 is going to go up here in the top left. 2 mole of N2. Like I said, if you are in moles of one substance, you can go to moles of another, and that's called the mole ratio step, and that's what I want you to call that. So this step is the ratio, the mole ratio step. So watch what you're doing. You can only do this if you have a balanced chemical equation, which this one is, and we're going to be using it. You do not want to be in moles of N2. You want to cancel that. The universal place to cancel is diagonal, so this is mole of N2 you're going to put down here. What do you want to be in? How many moles of hydrogen? H2. You want to be in mole of H2 on top. That's how I figured out where I wanted things to go. I didn't want to be in mole of N2, I wanted to cancel it. Whatever you want to be in is going to go on top, okay, from reading the problem. Now, where do these numbers come from? You use the balanced chemical equation. In this case, what is the coefficient in front of N2? If there's nothing there, there's a hidden 1. So I put 1 there. What is the coefficient in front of H2? Coefficient is the large number in front of the compound or element. In this case, that's a 3. So all you did is you just found the coefficients from in front of the balanced chemical equation, in front of the elements or the compounds, and you put them here for the ratio step. That is going to cancel moles of the substance and send you into a new substance entirely. So here's your work. Multiply the numbers on top, divide by bottom. This is 2 times 3 divided by 1. And in parentheses, just for funsies. So this is 6 divided by 1, that'll be 6. What is your answer and unit? Your unit in substance is whatever's in the top right box. So this is 6 mole of H2. That is seriously how easy a mole-to-mole problem is. And just remember, all you're doing is moving from mole of one substance to another. That's what you did. And you do all the rest the same. You are now masters of mole-to-mole problems.